To understand the concept of decimals is to understand our number system. Our number system is a place value system, which is base 10. Let's take a quick look at the place value chart. The dot in the middle is the decimal point that marks the difference between the whole number places on the left and the decimal number or the decimal fraction on the right. The first digit to the left of the decimal point represents the units, or the ones place. But what does base 10 mean? Look closely. Every time a digit moves from one place to the left, the value increases 10 times. From the ones place, 10 times its value would be the tens place. Moving one place to the left means 10 times more. So now we have the hundredths place. Moving further left is again 10 times the previous, which is the thousandths place. 10 times more is the 10,000ths place, and one place further is the 100,000ths place. And so, if moving to the left of the decimal point increases the value by 10 times, what will happen if we move the digit one place to the right? Moving the digit one place to the right of the decimal point means decreasing the value by 10 times. It means the first digit to the right of the decimal point is divided by 10, or what we call the tenths place. The next digit is 10 times less, so this time it's divided by 100, or the hundredths place. The next digit is again 10 times less than the previous, which is divided by 1,000, or the thousandths place. The same idea applies to the next one. Moving one place further to the right, the value is again 10 times less than the previous, which is then divided by 10,000, or the 10,000ths place. And moving even further is divided by 100,000, or the 100,000ths place. What have you noticed with the decimal number? The decimal number is expressed as a fraction where the denominator is 10 or other powers of 10. That is why we can say that decimals are special fractions where the denominators are all powers of 10. Let's look at this example. Decimals are special fractions where the denominators are 10 or any powers of 10. Let's complete these fractions by adding the numerators 7, 91, 53, 614, and 826. How do we change these fractions to decimals? That's very simple. All the given fractions are less than 1. We might as well indicate that in the ones place there is nothing, so we write 0 followed by the decimal point. The number of zeros tells you the number of decimal places. For the first example, 7 over 10, 10 consists of just one zero, which means only one decimal place is required. And therefore, 7 is already enough to fill that space. So, 7 over 10 can be written as 0.7. For 91 over 100, there are 2 zeros in 100, so you need 2 decimal places. 9 and 1 can fill the space just fine. For 53 over 1,000, you would need 3 decimal places. So we get 3, 5, and an empty space. What should we do with this empty space? Fill the empty space with 0. But why 0? Why can we not use any other digits? That is because 0 takes the place but doesn't change the value. Using another digit will definitely change the value of the given number. The same concept goes for the next one. 10,000 has 4 zeros, which indicate 4 decimal places. But 614 is only a 3-digit number, so again, adding a 0 is required to complete the decimal number. And lastly, 100,000 consists of 5 zeros, which then require 5 decimal places. However, 8, 2, and 6 only can make up for 3 decimal places, which means we need to add not only 1, but 2 zeros to complete the decimal number. As we said, decimals are special fractions with denominators of 10, 100, 1000, or other powers of 10. So how do you convert a fraction to a decimal where the denominator is not a power of 10? For example, 4 over 5, 9 and 3 over 4, and 8 over 250. How do you go about this? When the denominators are not powers of 10, we simply convert the denominator to 10 or any powers of 10. For the first fraction, the denominator is 5, can be multiplied by 2 to get 10. Do the same with 4, multiplied by 2, we get 8. 8 over 10 can now be converted to decimal as 0.8. Since the next fraction is a mixed number, there is no need to convert it to an improper fraction. Keep the whole number 9, and we will only work on the proper fraction 3 over 4. We can't change 4 to 10, but we can use 100 as the denominator by multiplying 4 with 25. Do the same with the numerator. 3 times 25 will give us a product of 75. And 75 over 100 in decimal can be written as 0.75. Altogether, we have 9.75. Finally, 8 over 250. The denominator 250 can be multiplied by 4 to get 1000. Do the same with 8. Multiplied by 4, we get 32. And 32 over 1000 can be converted to 0.032. How do you change decimals to fractions? Be reminded that decimals are special fractions with 10 or other powers of 10 as the denominator. Let's try this one. 0.7. Write 7 as the numerator, and since 7 is a single digit to the right of the decimal point, therefore the denominator goes with just 1 0, which is 10. What about 0.02? Just the same, keep the non-zero digit, which is 2, as the numerator, and since there are 2 digits to the right of the decimal point, the denominator goes with 2 zeros, which is 100. How about 0.039? Again, keep the non-zero digits 3 and 9 as the numerator, and since there are 3 decimal places, the denominator goes with 3 zeros that make 1000. Lastly, 3.015. How do you convert this into a fraction? We keep the whole number as it is, so 3 remains as 3, and for the decimal fraction, we will use the non-zero digits 1 and 5 as the numerator. Check how many decimal places to the right of the decimal point. These decimal places determines the number of zeros in the denominator. 3 decimal places means 3 zeros in the denominator, which makes 1000. What do you understand by expanded notation? Well, it only means writing a number to show the value of each digit. In other words, we could do this by multiplying each digit by its place value. But before we do expanded notation with decimal numbers, it is best to try expanding whole numbers first. How do you expand 7,296. We take one digit at a time and then multiply it by its place value. So 7 is multiplied by 1,000 because it is in the thousands place, plus the next digit 2 multiplied by 100 since it is in the hundreds place. Then 9 times 10 and 6 times 1. And that's it. It's too easy, isn't it? Now, let's try expanding the decimal number 0.4185. There are different ways to expand decimals. Be reminded that a decimal number is a fraction written in a special form where each digit represents the different powers of 10. So, to expand this decimal number, the first digit 4 will be expressed as a fraction with a denominator of 10, plus the next digit 1 expressed as a fraction with a denominator of 100, plus 8 over 1,000 and 5 over 10,000. Notice that the denominators are powers of 10. So how do you expand a combination of a whole number and a decimal number? For example, 54.26. Just the same, for the whole number, we must multiply each digit by its place value. So we have 5 times 10 plus 4 times 1. Then, add the decimal fraction 2 over 10 plus 6 over 100. We can also do expanded notation of decimals by showing the value of each digit in a decimal form. Earlier, we expanded 0.4185 this way, where each digit is expressed as fraction with powers of 10. Now let's expand the same number using decimals instead. So 4 over 10 can be expressed as 0.4 plus 1 over 100 as 0.01 plus 8 over 1,000 would be the same as 0.008 and 5 over 10,000 is the same as 0.0005. This time, try to expand this number by yourself. 0.3762. Show the value of each digit in decimal.